Welcome to the PhysiKey friends, and in today's video we will learn about important concept, universal law of gravitation. This concept can be understood using these 5 points. First one is what is gravitation or gravity. Second, universal law of gravitation. Third, factor affecting the universal gravitational force. Fourth, universal gravitational constant. And 5, importance of universal law of gravitation. So let us start the session. Okay, so the first point is what is gravitation or gravity. So it has been observed that if a body falls from some height from the surface of the earth, it always moves towards the surface of the earth. So earth attracts objects towards itself. Newton said that not only earth but any two objects, if you take in the universe, they will attract each other due to the force called gravitational force. So what basically gravitation is? What is the gravity? Or more generally, what is the gravity due to the earth? So gravity is the phenomenon. The gravity is the phenomena in which two objects in universe attract each other with help of gravitational force. Okay, so the gravity is a phenomenon in which two objects in the universe attract each other with the help of the gravitational force. So Newton generalized this idea and he gave the universal law of gravitation. Okay, so the second point is universal law of gravitation. So we know that what gravitational force is. So the gravitational force is the non-contact force of attraction exerted between two objects in the universe. So the gravitational force is non-contact force of attraction. Between two bodies, between any two bodies in universe. So the gravitational force is the non-contact force of attraction between any two bodies in the universe. Now, what is the numerical value? How to find out the numerical value of this universal force? What is the statement of universal law of gravitation? It is written like this: the attractive force between any two objects in universe is directly proportional to product of the masses and inversely proportional to square of the distance between them. This attractive force is acting along the line. It is acting along the line, joining the center of the two objects. Okay, so this is the statement. the attractive force between any two objects in universe is directly proportional to product of their masses. So let us highlight here the attractive force. What is the value of the force? Here, as you know that force is a vector quantity, so it needs magnitude as well as the direction. So again, gravitational force is a vector quantity. So what is the value of magnitude of force? The magnitude of force is directly proportional to, it is directly proportional to product of their masses. Okay, the attractive force between two objects in the universe is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, the square of the distance between them. So the value is depends on the product of the mass, value depends on the distance between two bodies. Again, direction of this gravitational force is along the line joining the center of the objects. So if we join the center of the object, and on that line the gravitational force will act. So for example, if we are having two objects, let me draw it here. If we are having two objects, like one object here, another object here, this is the center of the first object, this is the center of the second object. Let us say object first is A, object second is B. Let us consider the mass of the object A is m1 and mass of the object is B is m2. Mass of the object B is m2 and the distance between their centers is say D. Then the statement says that the value of gravitational force F is directly proportional to product of the masses. If I am multiplying the mass of m1 to the mass of m2, then that product is directly proportional to the value of F. Another thing is that the value of force is inversely proportional to the square of the distance between them. So the distance between the objects is d, then the force is proportional to the 1 by d square. Or you can say that force is inversely proportional to the square of the distance between them. Now combining these two equations, combining these two equations, we can say that the gravitational force is directly proportional to m1 into m2 divided by d square. So when you combine these two equations, you will get F that is directly proportional to m1 into m2 divided by d square. Now if we follow the mathematical procedure to remove this proportionality, we have to put one constant. So removing proportionality and putting the value of F, which is equal to G m1 into m2 by d square. Okay, where G is the constant of proportionality. Okay, then this equation, the squared equation, is the mathematical form, mathematical statement of universal law of gravitation, in which m1 is the mass of first object, m2 is the mass of another second object, d square means d is the distance between two objects. Okay, so where G is the universal gravitational constant. So this is the mathematical statement of the universal law of gravitation. As you know that gravitational force is one kind of force, so it is measured in Newton. So the gravitational force, whatever gravitational force is measured, okay, between two bodies, it is always measured in Newton. So its SI unit is Newton, or sometimes it is also called kilogram meter per second square. Okay, Newton is the kilogram meter per second square. Okay, so if we want to show the vector or show the direction of the force exerted between these two objects, then here let me specify the symbols for that. And for that case, you just see this figure here. If I am specifying the value F, that is the force on 1 due to 2, okay, so this F12 indicates force on 1, force on first object due to second object. Then you know that here which object is exerting the force? It is the second object exerting the force on first object. That is the meaning of this statement, this symbol, that F12 is the force on first object due to second object. So if I want to show you pictorially, then I should draw the arrow in this direction. So here the force is exerted on the first object by second object. So it has to be in this particular direction. So this arrow I can note it as a F12. So this arrow shows you the direction of force F12. Now if I am noting F21, then it is the force on second object due to first object, and this force has this kind of arrow and this kind of direction. So I should specify this as a F21. So the direction of force exerted on first object due to the second object is towards the second object side, toward the B object, whereas the direction of force exerted on the second object due to first object is towards the first object side. Another thing is that this law is called universal law of gravitation. Why? Because this law can be applied to any objects in the universe and between any two objects in the universe. So you can understand the gravitational force will exert on any objects in the universe. So that's why this law is called universal law of gravitation. Okay, so the next point is the universal gravitational constant G. So as we know that the equation F G m1 into m2 divided by d square for those two bodies having mass m1 and m2 separated by distance d, we are having the capital G. So this capital G is called universal gravitational constant. We have kept this constant in place of the proportionality sign. So the G is a constant and its value is 6.67 10 to power minus 11 Newton meter square per kg square. Okay, so the unit of universal gravitational constant G is a 6.67 10 to power minus 11 Newton meter square per kg square. Now if you want to derive Newton meter square plus kg square, so you just put the values of units in on both the sides. So force is measured in Newton, value of G we want to find, okay, unit of G we want to find, mass is measured in kilogram, another mass is also kilogram, and distance square is in the meter square. So the unit of G is a Newton into meter square per kg square. Okay, so you can derive the unit of G like this. Now why it is called universal gravitational constant? Because the value of G, value of capital G, universal gravitational constant, is not going to change at any position or any place in the entire universe. So that's why it is called universal gravitational constant. Another thing is that the value of G does not depend on the mass of the objects. Okay, so here I have to note that value of G does not depends on masses of two object. It also not depends on the distance between the object and distance between two objects. So whatever value which we are getting here, 6.67 10 to power minus 11 Newton meter square per kg square is independent from masses of the two objects as well as the distance between two objects. So that's why it is called universal, because universal means that its value is fixed, it doesn't depend, it is not depending on any other parameter of the two objects. Now let us focus on this equation. What happens if we put the value of masses here? If mass is m1 is equal to m2, it is equal to 1 kilogram, and distance between them d is equal to 1 meter. In that case, what is the force? Force is equal to g into 1 divided by 1 whole square, and that is equal to g. So if I want to define the universal gravitational constant based on the value of masses and the distance between two masses, then the universal gravitational constant G is the force F acting between two 1 kilogram mass object, 1 kilogram object separated by 1 meter distance. Okay, so if I want to define what is the universal gravitational constant G in terms of masses and the distance between two objects, then the universal gravitational constant G is the force acting between two 1 kilogram objects separated by 1 meter distance. So if you will measure this thing, what is the gravitational force between two 1 kilogram objects separated by 1 meter distance, then the force exactly equal to the value of G. Okay, so if someone asks that what is the amount of force exerted between two 1 kilogram object separated by 1 meter distance, then the value of force is equal to value of the G. So you can pictorially show like that. If this is the 1 kilogram object, this is 1 kilogram object, the distance between them is 1 meter, then the value of force is equal to 6.67 10 to power minus 11 Newton. Okay, so here we can point out this thing here, because sometimes higher order thinking concepts can be asked. So the force exerted between two 1 kilogram object separated by 1 meter distance is 6.67 10 to power minus 11 Newton. Now the next point is, what are the factors which are affecting the value of force F? So we know that the equation is F is equal to G m1 into m2 by d square. So here you can see that if someone changes the masses, then again the value of force will change. So since the masses are and force are related with the direct proportionality, so if masses are going to change, then value of force is going to change. Okay, so if mass of any one object gets double, force will be double. And if mass of any object is getting half, then the force will be half. Okay, so if mass of any object is getting double, any one object, okay, I should specify here any one object, only one object. If we are changing the masses in both the object, then accordingly the change will appear. Now another thing is that the value of force is also depending on the distance. So if distance between two object gets double, in that case you can say that distance is related to the force inversely proportionality and square wise. So the force will be 1/4 time. Okay, so the force will reduce by the factor 4. So if you can say that if the distance between the object gets halved, in that case the force will be of 4 times. Okay, so here you can see the change. If the distance between two objects get double, then the force will be 1/4 time of the total initial one, and if the distance between the two objects gets half, then the force will be 4 times. So here the force is depending square wise on the distance between two objects. So that's why the force law is called inverse square law. Okay, so the force is inversely proportional to the square of the distance. So that's why this force and the statement is also called inverse square law. So the gravitational law, the gravitational force law is inverse square law. Shows inverse square dependence on distance. Okay, so the gravitational force law is inverse square law. Okay, why we are telling this gravitational law as a inverse square law? Because this force shows inverse square dependence on the distance. So this is the very important point of the discussion, that what are those factors affecting the value of the gravitational force. Okay, so the last and the fifth point is importance of the universal law of gravitation. What is the importance of this law? So this force, gravitational force, binds us to the earth. This is the first point. Second point, the motion of the moon around the earth and the motion of the planets around the sun. These motions are only possible if there is a gravitational force between the sun and the planets, as well as the earth and the moon. The tides due to the gravitational force between moon and earth, and the gravitational force between sun and earth. So if the tides in the ocean can be only there if there is a gravitational force between moon and earth is there, and the gravitational force between sun and earth is there. The last point is that flow of water in river due to the gravitational force of earth on water. So rivers are flowing, okay, with the water, okay, lots of water, because the gravitational force of earth is acting on the water in the river, and due to which rivers flows from one point to the another point on the surface of the earth. So this is all about this universal law of gravitation and the topic gravitation. If you have not subscribed to my channel, please subscribe my channel and hit that like button.